Good morning, class, and welcome to Chapter 2, Limits, Section 2.1, Limits of Sequences, and the session is being recorded. So if anybody has any issue with privacy, make sure your audio video is muted, and even your name, you can change it to your initials. I don't think that's a big deal because it's just being used for you and your fellow students. All right. So here's the synopsis of what we did. We looked at limits of sequences. First, we started looking at the definition of a sequence we had seen before, which is simply a list of numbers. And it is written in a specific order, a sub 1 all the way to a sub n, where a sub 1 is the first term, and a sub 2 is the second, and a sub n is the nth term, the general term. Then we looked at the recursive or sequence difference equation, recursive sequence or difference equation in the form of a sub n plus 1 equals f of a sub n, meaning if we are interested in coming up with a term, we need the term or terms prior to that. Example of that would be a Fibonacci sequence we have seen before. We also looked at arithmetic sequence class, okay. Which basically starts with the first term and then we add a constant t. A geometric sequence, it starts with the first term and we multiply by a constant r. The recursive format for arithmetic sequence gives us a sub n plus 1 equals a sub n plus a constant d. For geometric sequence gives us a sub n times a constant r. Okay, and explicit formula was also discussed for arithmetic sequences. A sub n equals a sub 1 plus n minus 1 times d. Okay, and for a geometric one is a sub n equals a sub 1 times r to the power of n minus 1. Then we looked at limits of sequences and we went over the summary, and in general, the limit refers to what happens in the long run, what happens when n goes to infinity. When you can pinpoint the limit and say the limit exists and it's equal to some number such as L, we say it converges to L, it is convergent, the sequence. If it tends infinity or negative infinity, that means it blows up to infinity or negative infinity, or if it doesn't exist, like it oscillates between two numbers, then we say the sequence diverges. Then we looked at the sum for the geometric sequence and some theorems that we will discuss further. In this example, we looked at the first few terms to make a decision as to what's happening. For example, the first one seems to be getting smaller and smaller, and it converges to 0, whereas in the second part, it just oscillates between the two numbers, in this case, -1 and +1. So it does not exist, the limit, and it's divergent. Again, we repeated the definition as far as convergence and divergence is concerned. In short, convergence means you can come up with a limit, you can come up with a value, and divergence means it can't happen. Okay. In this example, we cut this into two fractions, and we use the fact that the base is a number between -1 and +1, so makes that go to 0. Each piece goes to 0 and the result is 0. The first three cases, we just replace the n with its value. It happened to be infinity and we observed. The first one becomes infinity, the second one 5, and the last one 1. In part D, we are dealing with a rational expression. As n goes to infinity, the methodology is to divide by highest degree term in the denominator and observe. Same thing on this page. We divided the top and the bottom by the highest degree term in the denominator, okay? In the first case is n squared, in the second case is n. In this example, we wanted to write the first 8 terms, and I showed you how to find the first and the second one with details, and then I mentioned this may get difficult, it is tedious, and therefore what we did, we went over using a short program using a graphing calculator, okay? This is in case you're doing your homework and it's difficult, and it's tedious, it takes long for the purpose of that. Finally, so the table indicates the second column, that the limit goes to 0.75. And finally, we looked at that algebraically, and we proved the limit is 3/4, which is the same as 0.75. Again, refreshing your memory about the arithmetic and a geometric sequence. So that is the synopsis of what we covered. And now, although you've seen this proof, but let's quickly go over that. This is in algebra. We want to prove a sum is equal to what? And in this case, when you write the sum class, as far as terminology is called the geometric series instead of a sequence. So basically, we're going to look at S sub n, and we're going to multiply this by R. Okay. I'm going to stop the video because sometimes it makes it blurry, class. By the way, let me know if by any chance in your end things are blurry and it's hard to follow. Okay. So now, if we subtract, so we are multiplying the first one by R. So this A becomes AR. This becomes AR squared. And this last one becomes AR to the power of n. Now subtract the second line from the first line. These two cancel out. Everything cancels out except A and A times R to the power of n. So S sub n minus R S sub n, okay, equals A minus A R to the power of n. On the left side, we factor out S sub n. On the right side, we factor out A. If you divide by 1 minus R, that gives you S sub n. So this is the proof, you've seen it before. Okay, everybody? Now, when R is between -1 and 1, we know that R to the power of n goes to 0. So if R to the power of n goes to 0, the top is A times 1 minus 0, or simply A. And we're going to use to apply to some questions. Okay. So here's what happens. We want to add up these numbers. We notice it follows a geometric sequence with the first term being 1/2. What is the ratio? 1/2 times what number is 1/4? You can see that it's 1/2, or you can divide 1/4 by 1/2. You can divide 1/8 by 1/4, so on and so forth. And you get the ratio of 1/2. Again, just as an example, class, if you divide the second term by the first term, you see the R, okay, class? So therefore, we can use this formula. A over 1 minus R, A is 1/2, R happen to be the same thing. Okay, everyone? And so what happens next? 1 minus 1/2 is 1/2. 1/2 over 1/2 is 1/2. Class, if you want, you can change this to 1/2. Here's another example. express this as a rational number, 0.46 bar. I hope you know that 0.46 bar means 0.46. Keep on going, 46, 46, 46. And there are two ways to write this. You can write it using fractions. The first two would be 46 over 100. The second set, 46, would be 46 over what? 10,000 or 100 squared, and so on and so forth. If you feel more comfortable with the decimals, you can write them as decimals. This is class the same as writing 0.46 plus 0.0046 and keep on going. Okay. All right. So if this is the case, your first term is 46 over 100. And I hope you see that you're dividing by 100. So 1 over 100 is the common ratio. And I don't want to simplify this for one reason, because I don't want anybody to get confused. I want to keep it as such, and eventually, if need be simplified. So following this, A over 1 minus R, A is 46 over 100. 1 minus R is 1 over 100. This is a complex fraction. The simplest way to handle a complex fraction, we're going to multiply the top and the bottom by 100. The top changes to 46, and the bottom becomes 100 minus 1. If you multiply this one by 1 is 100, and this one by this one, takes away the denominator, so it becomes 99. And it can't get simplified, you're done. By the way, there is an algebraic way of doing that. I highly recommend you look it up, it's interesting, okay? So expressing the number as a rational number. Here's the next one. 5.75 bar, it's very similar to that. It's the same as 5 plus 0.75 bar. Okay, the 0.75 bar, it's similar to 0.46 bar. Okay, so 75 over 100 plus 75 over 100 squared and so forth. So this portion follows a geometric sequence just like this, where the first term is this, but the R is the same R, 1 over 100. So this portion follows that, not the number 5 in front. So that part we are going to use just like this, using this A, which is 75 over 100 over 1 minus R, or 1 minus 1 over 100. So the 5 remains intact, and this one we change it. Again, 75 over 100 can be simplified. Yes, I don't want to simplify it. You'll see, in fact, because the denominator is 1 minus 1 over 100, I'd rather keep it that way. It's fast in that. Again, we do the same thing. What did we do here? Complex fraction. We're going to multiply by 100 over 100. So this part, the top becomes 75, the bottom becomes 100 minus 1, which is 99. This fraction, we can simplify, everybody. Both of them are divisible by 3, and this is your final answer. Now, as far as I'm concerned, this is a perfect answer, and you're done. They may want you, because they're asking for a rational number, they may want you to write this as 5 times 33 plus 25 over 33, the improper format. Okay, class? For me, it makes no difference. All right. Let's refresh your memory again about the basic geometric recursion we've seen, or geometric sequence. There's really not much to it. This is being repeated. What happens when n is 0? Plug in 1 and 2. So if n is 0, we get 2 to the power of 0, 1, 1 times 3 is 3. If it's 1, 2 times 3 is 6. If it's 2, 2 squared, 4 times 3 is 12, so on and so forth. So this is the geometric sequence, and the recursive form, as you remember, b sub n plus 1 was r b sub n, and we just we are multiplying by what number? We are multiplying by 2, so 2 b sub n. Where the first term, sometimes they call it b sub 0, sometimes they call it a, and I write both of them because it really depends on the text that you're dealing with, class. What we want to do, we want to modify this geometric recursion by adding a constant. So this one, class, b sub n plus 1 equals r b sub n, we want to add a constant. And this is used in application, for example, when we are dealing with patients and we give them medications on a regular basis. That regular basis is called the time step. Every day, every week, every 4 hours, okay? R is the amount of drug that remains in the body, and C is a fixed amount. It can be shown that the solution to this is b sub 0 or a r to the power of n plus c times 1 minus r to the power of n over 1 minus r. And so in general, a or b sub 0 are the same. The solution is this, and I have this at the end of the PowerPoint. You can look at it. It's also in your text. You're not responsible for it. Let's look at some examples involving this concept. At the top, I am giving you the formula and the solution. So we want to solve the difference equation in this example. B sub n plus 1 equals 0.b sub n plus 4, where b sub 0 is given to be number 5. And when we are done, we want to find the limit. Okay, everybody? So let's see how we do that. Anytime you deal with a case like this, it is extremely important that you be able to write the given. So what I'd like you to do is very simple. Look at this and compare it to this part. First of all, B0 equals A equals 5 is given. Then compare this one to this one. RB sub n, so R is 0.8. Plus C plus 4, so C is 4. I hope everybody can see that. We are comparing and we are making a decision, everybody. We are comparing and we are making a decision. It's very straightforward. I hope everybody is okay with that. All right, so what happens next? Now that we have that, we're going to go here, everybody. We're going to go here and we're going to plug in. What is B sub 0 or A? 5. What is R? 0.8. What is lowercase c? 4. Again, what is R? 0.8. So in this equation, so B sub n equals this, plug in. So when you write the given, it really makes your life easy, class. Plug in. So you see that? Plug in. Okay. And so what happens next? I hope everybody is following the plugin. Now we are going to simplify, and the methodology to simplify is as follows. Pay attention to this is 0.2, everybody. And so this part is 4 divided by 0.2, 1 minus 0.8 to the power of n. What is 4 divided by 0.2 is 40 divided by 2. So we end up with 20. Okay, everybody? Why are we writing it this way? This is ultimately to simplify it such that it becomes ready for the limit. That's the idea, class. Now, this one, class, you can think of it as x, 5 times x plus, now distribute the 20, 20 times 1 minus 20 times x. I'm distributing. If you have a problem with that, literally change this to x, class. 5x plus 20 times minus 20x. Are you with me? If you have a difficult time going from here to here. Now 5x and minus 20x, they add up to negative 15x. In other words, this one and this one, they add up to negative 15x or negative 15.8 to the power of n. I can't really emphasize this enough. I hope everybody is comfortable with that. If you're uncomfortable with that, what do? You change that to x. I can't emphasize this enough, class. Okay, change that to x. Okay, everybody, change that to x, and it will make a perfect sense to you. So again, change that to x. All right. So now that we have that, we are going to take a limit. So let's just write the limit. That's all. We are going to write the limit and observe, see what happens. Well, when n approaches infinity, everybody, this guy goes to 0. Why is that? Because 0.8 is between negative 1 and 1. This goes to 0. Minus 15 times 0 goes to 0. The answer is 20. Okay. Again, pretty straightforward. I hope everybody's okay with this. Sounds good. I'm going to go to the next question. Anybody feels like reading this for us? Again, you don't have to participate if you don't want to. Anybody would like to read this for us?
I can.
Please.
Example 5. A patient is injected with the drug every 12 hours. Concentration will be reduced by 90% before each injection, and the new dose increases the concentration by 1.5 milligrams per milliliter. What is the concentration after 3 dosages? Write the expression for Cn plus 1 in terms of Cn. Find the formula for Cn as a function of n, and what is the limiting value of the concentration?
Thank you so much. Okay, class. Couple of things. First and foremost, as far as the reading is concerned, class, just to make sure, this is C sub n plus 1. This is C sub n. This is C sub n. The second thing is that this is a word problem. So when you have a word problem, you need to know what's given. Okay. So what we want to do now, we want to compare to this and see what's given. And before even we do that, part tells us that instead of B, we are using C. Do you see that? So not a big deal. So instead of B sub n plus 1, we're going to go with C sub n plus 1, which means anywhere you see lowercase b, you change it to capital C. That's the idea. Now, what is given? Let's start one by one. The very first number is 12 hours. That's a time step. It doesn't enter any of the calculations. It is extremely important, but doesn't enter. And if you have any doubts, in your mind, say, okay, every 10 hours, every 24 hours, every week. It doesn't enter the calculation, but it is important. Now, Concentration will be reduced by 90% before each injection. Now look at this one. Can we figure out anything from this 90% class? Anyone? What matters is what remains in the body. Concentration will be reduced by 90%. So what is left? 10%. So R is 1 minus 90%. That means 0.1 or 10%. And then what happens? The new dose is given, and that's a constant amount, lowercase c, of 1.5 milligrams per milliliters. Dealing with the patients, B sub 0 equals A. In this case, we say C sub 0 equals A. It's always 0. In the case of patients, this is always 0 unless it's mentioned somehow that it's not. Okay? It is always 0. They want us to write the first 3 dosage, but before we did that, we wrote the given. If you write the given, it makes life easy to do the rest. So the very first one, n equals 1 gives us 1.5. N equals 2, we have 10% of 1.5 left, which is 0.15, and we add 1.5, gives us 1.65. So take a look. Number 1 gives us 1.5. Number 2, 10% of this 1.5 gives us another 1.5, adds up to 1.65, because this is 0.15, everybody, okay? Now, 10% of this amount is 0.165, and it's added to 1.5, and this is after the third one. Okay. We are going to write part B. We are going to write the expression for C sub n plus 1. So in this expression, B changes to C. So look at this one, everybody. Change the lowercase b to uppercase C. So that's the first thing we do. Now, given, put it in. I hope you realize why we wrote the given and how important this is. Look at the given. Look at the given, everybody. I need R. I know R is 0.1. Good. I'm going to replace it. I need lowercase c. I wrote lowercase c is 1.5. I'm going to replace it, and I'm done. See how fast you can come up with the answer? First, this one, you change the B to C. Second one, put the given into that, and you're done with part B. Part C. We want to find the formula for C sub n. So we go to this formula, and first and foremost, we change the B, lowercase b, to capital C. Look at this formula. Write this formula, everybody. So lowercase b changes to capital C. Okay, so C sub 0 instead of A, R to the power of n, lowercase c doesn't, everything stays the same. So B sub n is changing to capital C sub n, B sub 0. You can change it to A if you want, but it's better to stick with C sub 0. Now that we have that, go back to the given, everybody. Go back to the given and plug in. Which means C sub 0, replace it with 0. R, replace it with 0.1. Lowercase c, replace it with 1.5. R, replace it with 0.1. So put the given in. Put the given in, everybody. Okay. And this is what you get. Now, it's just a matter of simplification. And to simplify, we do exactly what we did in the previous page, starting with this. And this goes to 0 because C sub 0 is 0. So now this is 1.5 over 0.9 times 1 minus 0.1 to the power of n. One 1.5 divided by 0.9 is the same as 15 over 9, which is 5/3. If you replace the n with 1, everybody, gives you 1.5, okay? Because it's 0.9 times 5/3. If you replace it with 2, it gives you 1.65. So if you replace the n with 1, 2, 3, gives you this table. So this can give you this table. Finally, what about the limit? Let's take a limit. So you're going to take the limit, everybody. So when you take a limit, what happens? Again, notice 0.1 is between -1 and +1. This goes to 0, 5/3 times 1 minus 0, or simply 5/3. And now put the units. Put the units and you're done. Put the units and you're done. And as I mentioned, class, you can change the n here to 1, 2, 3. It gives you the entire table. It gives you the entire table. It's very straightforward. Okay. Let's look at one more example to make sure we are comfortable with this. Here's what happens. Could somebody be kind enough to read this question for us? Again, you don't have to, but if you do that, I highly appreciate that.
I could read it.
Please.
A doctor prescribes a 100 milligram antibiotic tablet to be taken every 8 hours. Just before each tablet is taken, 20% of the drug present in the preceding time step remains in the body. How much drug is left after the third tablet? Write the expression for Q sub n plus 1 in terms of Q sub n. Find the formula for Q sub n as a function of n. What is the limiting value of the concentration?
Thank you so much. And again, we do the same thing, class. Number one, when we look at part B, everybody, when we look at part B, we see Q, that means B changes to Q, just for the sake of argument when we want to write. Number one. Number two, before we do anything, we want to write the given. This is a word problem. This is an application problem. Let's write the given. So how do we do that? Well, let's go with the numbers as we come across them. The very first number I see is 100 milligrams of antibiotic. What is that? Anybody, class, can tell me what that is? The very first number is 100 milligrams. So what is that? So we are reading the question. We want to dissect it and see if we understand what's given to us. So the very first number I see is 100 milligrams. What is that? Anyone?
C.
Beautiful. It's a lowercase c. It's the constant. Because it says every 8 hours, we're going to repeat the same thing, class. We're going to repeat this. This is not, this is constant, okay? This is being repeated. The next number I see 8 hours, and that is a time step. Extremely important, doesn't enter any calculations. Just before each tablet is taken, 20% remains in the body. What is that? Anyone? What is that number?
It's R.
Beautiful. It's the ratio R. So we are going to, and again, we're dealing with the patients to begin with. There is nothing A or B sub 0. And now we decided we're going to go with what? Q sub 0. That is 0. So Q sub 0 or A is 0. lowercase c, it's fixed at 100 milligrams of antibiotic, and 20% remains. So if I want to write this, I need to come up with a table. The first dose is 100. After the second one, 20% of 100, which is 20, is left, plus 100 makes it 120, and it moves on. So 20% of 100 gives you 20 plus 100. Now you put the 120 here. 20% of 120 is 24, everybody. And you add it to 100. So I hope you see how we arrive at it. Let's go to part B. In part B, what we do, we look at this formula and we change everything to Q. Do you see that? B changes to Q, everybody. B changes to Q. Let's do that. B changes to Q. And then we just go back to the given. That's all we do. Go back to the given and replace everything here. R 0.2, lowercase c, 100. I hope you appreciate the given. The given really makes life easy. If you write them, you can come up with the answer for each part extremely fast, everybody. Okay, we want to find the formula for Q sub n. Okay, here's the formula. We're going to change anywhere we see B to Q. First, let's change the B to Q, everybody, and put it here. B to Q. So Q sub n, instead of B sub 0, we're going to put Q sub 0, and everything else we just repeat. So again, we are changing it to Q because they are using Q. That's all. Okay. Back to the given. Back to the given, everybody. Plug in. Q sub 0 or A is 0. Lowercase c is 100. R is 0.2. Just plug in. And we're going to repeat the same process. We're going to change this to 0.8. And this goes to 0 because 0 times 0.2 to the power of n is 0. So this becomes 100 divided by 0.8 times 1 minus 0.2 to the power of n. And 100 divided by 0.8 is the same as 1000 divided by 8, which is 125. Again, if you replace the n with 1, everybody, you get 0.2. 1 minus 0.2 is 0.8. 0.8 times 125 gives you 100. That would be the first one. If you change it to 2, you get 120. If you change it to 3, you get 124. You can try it. Let's find the limit. So we're going to find the limit of Q sub n as n goes to infinity, which is the limit of this expression, everybody. Which is the limit of this expression. Okay. So what happens next? When n goes to infinity, 0.2 to the power of n goes to 0 because this is between -1 and 1. So 1 minus 0 is 1. The answer is 125. You go back, you see the units milligrams, then you must write the limits. So this limits ends up being 125 milligrams, which means no matter how many times you keep on giving 100 milligrams of medication to the patient, it will never ever go beyond 125 milligrams.